Okay, so let's look at this, and we're going to use it with your data table. Wow, that thing is really not focusing. Is that better? Yeah, okay. So when you look at this, there are two things on here that I really want you to pay attention to. First of all, this whole thing is called the electromagnetic spectrum. You should know that. And this one shows you from radio waves all the way through gamma rays. If you look at the bottom, does everybody see that? Yeah? So the bottom part, this right in here, shows me both frequency and wavelength. So just go ahead and write this stuff on here. Remember, frequency looks like the V, wavelength is lambda, lambda nu. Think of frequency as how fast. How fast is the wave traveling? Now, do you see this running through the bottom gray part? Those are the waves, the wavelength. What happens to the wavelength as I move towards violet light or towards gamma rays? What's happening to the wavelength? It's going up or going down? Getting longer or shorter? Maybe that's another way to say it. Fletch? Shorter. It's decreasing. So, as I move this way, my wavelength decreases. So, if I ask you to compare yellow light to blue light in terms of wavelength, which one has shorter wavelength? Yellow or blue? Yeah, good, blue. Now, what's happening to the frequency of the waves? Are they traveling faster here or here? Yep. Down here? Yep. So as I move this way, what happens to frequency? Does it go up or down? Up. Kennedy's telling me up. So this way, my frequency increases. So who's traveling faster? Yellow light or red light? What, Anthony? Yellow. That's right. So radio waves will have the longest wavelength. They're part of this electromagnetic spectrum that we can't see. This visible light part that's broken out up here, it's not very big, is it? All the color we see doesn't fall in a very big part of the electromagnetic spectrum. So radio waves through gamma waves are the electromagnetic spectrum. I would kind of put a star by that and be sure that you can talk about the order in which they come. That you could rank them for me, like which one's the fastest, which one's the slowest, shortest wavelength, longest wavelength. Now, I pulled up, I think it was Connor's a minute ago, and I looked on your table. We have wavelength and we have frequency, right? Do we have energy on there? Okay. So what I want you to do right now, I want you to get together with your lab partner, and I want you to rank those colors that you saw based on this, where like, let's make this 1, and then your blue. So you've got your Roy, do you remember this from grade school? Roy G. Biv. Red, orange, yellow, green, blue, indigo, violet. Did you learn that? Yeah, okay. So I want you to label them in terms of wavelength with 1. Let's make 1 the shortest. And you'll count your chemicals. I think you should have 10 or 11. Whatever your last number is would be the longest. So go shortest to longest when you rank them. in terms of wavelength. And then for frequency, let's make number 1 the highest and number whatever the lowest, number 11. Okay? Does that make sense? Yeah? Okay, let's do that first. Wake up, people.